Okay, so for this particular lesson, we are going to talk about probability, and the probability of an event is the measure of the likelihood or the chance that a certain event is going to occur. The probability is a number that's going to be from 0 to 1 and can be expressed as either a decimal, a fraction, or a percent. So basically, if you've got a 0 chance of something happening, it's impossible that it's going to happen. And that goes across the continuum of being a 25% chance, 0.25, 1/4, that's unlikely, equal chance it's going to happen, it's equally likely, um, the chance of tossing a heads on a coin would be, 1 out of 2. It's equally likely to be yes heads or no heads. Extremely likely or absolutely for certain. So that's where your numbers go between 0 and 1. The outcome happens to be the result that occurs after simulating some sort of experiment, tossing a coin, rolling a die. The complement is the chance that an event will not occur. So if you take the ways that something can happen and the ways that that thing can't happen, an event and its complement have to add to a whole. Talking about the sample space, it's going to be the set of all possible outcomes. And then we also talk about theoretical probability. And theoretical probability, it's a ratio or it's a fraction. It's the number of ways that an event can occur to the possible number of outcomes. So the probability P of an event happening, okay, theoretically would be the number of favorable outcomes over the total number of outcomes that exist. Okay, so let's get to this particular sheet. We just talked about theoretical anyway, so this is, I don't know, I've got a couple of the same slides. But if we want to determine the probability of getting a heads if we toss a coin once, well, there's 2 sides to a coin, and only one of those sides is heads. So it's a 1 out of 2 chance that you're going to get a heads. If you roll a die 1 time, well, there's 6 sides to every die. The number that's going to be, the probability of rolling a number greater than 6 is never going to happen, right? Because there's no numbers greater than 6. If you spin a spinner with the numbers 1 to 6, the probability of getting an even number, well, again, spinning a spinner, there's 6 outcomes, but even numbers, there's 3 evens, a 2, a 4, and a 6. So it's a 3 out of 6. If you pick a card at random from a deck of cards, let's talk about cards for a second. So this is very important. So cards, there happen to be 52 cards in a deck. We're not talking about jokers. We're talking about everything else. There happen to be 26 red cards, and there happen to be 26 black. Red cards consist of diamonds and hearts, right? So you got diamonds, you've got hearts, okay? And the numbers are from ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So there's 13 red cards. Hearts, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. 13 of those. Black cards, bear with my drawings here. These are the spades. Kind of shade that thing in. And there happen to be 13 of those also. And then there are clubs. It's like kind of like a 4-leaf clover. That's not really great, but that's good enough. And there's ace to king, 13. So we've got clubs. We've got spades. You've got hearts. And you've got diamonds. You need to know cards, okay? It's expected that you know cards. I'm going to go back here for a second. So what's the probability that I pick a club out of a deck of cards? And the probability would be, well, there's 13 clubs out of 52 cards. Now it's asking for the complement of the probability from 2. So 2, we're talking about any way that I can get a number greater than 6 on a die. Well, there's 0 out of 6 ways I can get greater than 6, which means there's 6 out of 6 ways to not get something greater or to get something less than 6. So this is going to be 1 whole. The complement of the probability in 4, Well, 4 is if there's 13 clubs out of 52 cards, then there are 39 cards out of 52 that are not clubs. Okay, so you're looking for the complement, not clubs, not greater than 6, etc., etc. Okay. This is the card stuff. A gumball machine contains gumballs of 5 different colors: 36 red, 44 white, 15 blue, 20 green, and 5 orange. The machine's dispenser randomly selects one gumball. What's the probability the gumball selected is? And you got to figure it out. Well, the total number of gumballs, if you add everything up, is 120. So green gumballs, there are 20 out of 120. Don't worry about simplifying these, by the way. Just keep them as is. The complement of green, well, if 20 out of 120 are green, then 120 minus 20, or 100 out of 120 are not green. The complement of orange, everything that's not orange. There are 115 out of 120 gumballs that are not orange. What is orange is just 5 out of the 120. Not a color in the flag of the United States of America. Well, if you're not a color in the flag of the US of A, then you have to be green or orange. So really we're looking for the greens or the oranges. If we add those things up, we're going to get 25 out of the 120. Red, white, or blue will be everything that's not green or orange, which means red, white, and blues add up to 95 out of 120. Okay, let's keep going. Experimental probability is based on repeated trials of an experiment. So experimental probability says how many ways did you get what you wanted, number of successes, out of how many times did you try to get what you wanted. So each section of the spinner shown has the same area. The spinner was spun 20 times. So this would be the number of trials, okay? 20 times is the number of trials. So the table below shows the results. Find the experimental probabilities. Well, red. We spun red 5 times out of our 20 trials. Green or blue, we spun 12 times out of our 20 trials. Anything that was not yellow, well, there was 3 yellows, which means there were 17 not yellow. For which color is experimental probability the same of stopping on the color, the same as the theoretical probability? Well, theoretically, every single color over here, whether you're red, green, yellow, or blue, there's a 1 in 4 chance theoretical probability. There's a 1 in 4 chance of the theoretical probability that you're going to spin a color. So which one of the probabilities experimentally will give you a 1 out of 4? And that would be the spinning of red, because red that we can see already is 5 out of 20. If we did simplify it, it's 1 out of 4. So red has the same experimental and theoretical probability. Okay? And that's it. So good luck on the homework.